In this notebook, we'll be building a generative adversarial network trained on the MNIST dataset. From this, we'll be able to generate new handwritten digits that should look like they've come from the original training set. If you'd like to read the original 2014 paper on GANs, I've included a link here, plus a couple other really cool resources for you to check out. These are basically a sampling of GAN architectures and tasks that GANs can be applied to. We'll specifically learn more about pix-to-pix and cycle-GAN architectures later on in this program. The idea behind GANs is that you have these two networks, a generator G and a discriminator D, and they're competing against one another. The discriminator is a simple classifier that looks at an input image from either our real training data or our fake generated image data, and it tries to label that image as fake or real, which are values between 0 and 1. As a GAN trains, the discriminator gets better at distinguishing real and fake images, and simultaneously the generator gets better at generating fake images. After some number of epochs, the generator should learn to make data that is indistinguishable from real data, according to the discriminator. Now, one thing to note is that the generator has to start with some input, and it will transform that input into a new image. This input is going to be a random vector, sometimes called a latent vector. The idea here is to create a latent vector space that we can mathematically operate on. As the generator trains, it figures out how to map any latent vector to an image of a digit that can fool the discriminator. Now, if your goal is to generate only new images, you can discard the discriminator after training and keep only the trained generator. Okay, so in this notebook, I'll show you how to define and train these adversarial networks in PyTorch and generate new images. First, I'm going to load in my usual libraries, and then I'm loading in my MNIST data, here using PyTorch's built-in datasets and a data loader for batching this data into batches of size 64. In this case, I'm really only interested in the training data. Specifically, I want to train a generator to make new data that looks like it could have come from this training data, and so I'm just loading in that training data here. Test data would be more useful in a classic classification example. Then, after I've loaded in my data, I'm going to visualize an image to make sure it's as I expect. So I'm getting a batch of data from our data loader, and just displaying the first one in there. So here's an image of a 5, and recall that these are all grayscale 28 by 28 images. Next, we'll want to define our GAN. But before I outline this exercise and model definition, next I'll give you a chance to access this notebook. I recommend that you open the exercise notebook in one tab and follow along with these videos in another as I go about defining and training this complete model.